Hello everyone, all my dear students. Today we are going to learn the frequency modulation. We are not going to study the electronic circuitry involved in the frequency modulation. We are going to learn the process of a frequency modulation, and the process of frequency modulation. It means here we have to see what happens if we do the frequency modulation. So as we seen, in amplitude modulation, here the amplitude modulation and the frequency modulation having one difference, and that major difference is in the amplitude modulation. The amplitude of a carrier signal is changed, but here in this case the frequency of a carrier signal is changed. So let's go on the computer screen. If you will understand this video lecture what is the frequency modulation, then hit the like button, subscribe the channel. So the frequency modulation, we have to see frequency, as its name indicates, it is a frequency modulation. So the frequency modulation is the modulation in which the frequency of a carrier signal is changed in accordance with the modulating signal. Now we have to see the definition of the frequency modulation. The frequency modulation is the process of modulation. The frequency modulation is the process of modulation in which the frequency of a high frequency carrier signal, we can say the RF signal, the frequency of a carrier signal is changed in accordance with the instantaneous amplitude. Instantaneous amplitude means the amplitude at a particular instant, that is we call instantaneous. Means the frequency of a carrier signal is changed in accordance with the instantaneous amplitude of a modulating signal, by keeping the other characteristics such as the amplitude and phase of a carrier signal constant. This process is we call as the frequency modulation. So in frequency modulation, the frequency of a carrier signal, is changed in accordance with the instantaneous amplitude of a modulating signal. In short, we consider here the frequency modulator circuit, and then we will see the waveforms. Now here this is a frequency modulator. This one is a frequency modulator circuit. The input to the frequency modulator is this one, the audio signal, and this is we call as modulating signal. The audio signal or video signal or any other type of the signal, we say here this is the information, and this information signal is we call as modulating signal. So here it is the modulating input. Then one more input we applied, that input is the carrier signal. That input is the carrier signal, or we can say the carrier input. The resulting output is we call as the FM signal. Means here the process is very simple. The two inputs are involved, and these two inputs are the modulating signal, and second one is the carrier input signal. The modulating signal is the low frequency signal, and the carrier signal is the high frequency signal. So here it is the input, we can say it is the input signal. The input signal is having the important characteristics. That characteristics is the amplitude, and here as the amplitude, we can consider that amplitude increases or decreases from the 0 volts. Means if we see the waveform, then its waveform is like this. I am going to draw here the waveform. So waveform is like the sine waveform. Here the reference voltage is equals to 0 volts. So from the 0 volts it starts increasing towards the maximum value. That maximum value is we call as a peak voltage, and again start decreasing towards the 0 reference voltage. After the 0 voltage, here it again decreases towards the negative peak value minus Vp. Okay, so this is the value of a modulating signal, like a sine wave signal we can say. Here the modulating signal increases or decreases. As the modulating signal increases or decreases, here the FM signal, or you can say the carrier signal frequency also increases and decreases. Means if we draw here one simple diagram, then we can say here if the amplitude is increased, here the amplitude is increasing, means the frequency is also increasing. If the amplitude is maximum peak value, the frequency is maximum here, that is we call F maximum. Now the amplitude is decreasing from its maximum value towards the zero, then the frequency is also decreasing to its original frequency. That original frequency is we call the center frequency. That frequency is we call as a resting frequency. That frequency is we also call as a carrier frequency. Now the amplitude of the modulating signal start decreasing from 0 to its negative peak value, then the frequency of a signal, the carrier signal, also start decreasing, and here it attain its minimum frequency at the minus Vp. That frequency is we call as a minimum frequency. Okay, now the change in these two frequencies, from minimum to maximum, that is we call as a carrier swing. This is we call carrier swing. And the change of frequency from its center frequency, from its original frequency to the maximum value, from original frequency to the minimum value, that is we call FD, frequency deviation. So the frequency deviation is the change in the frequency. It is the change in the frequency of a carrier signal from its minimum, from its center frequency to the maximum, and from center frequency to the minimum. Means when the frequency modulation is done, the frequency of a carrier signal changes from its resting frequency, changes from its carrier frequency, changes from its original frequency to the maximum, and from maximum to the original. This is we call as a frequency deviation. The frequency of a carrier signal is we also call as a center frequency or the resting frequency. The total amount of change from minimum to maximum is we call as a carrier swing. Okay, so in this way the frequency of a carrier is changed. Once again we will say the principle of the FM in terms of a definition. So the frequency modulation is the process of modulation in which the frequency of a carrier signal changes in accordance with the change in the amplitude of instantaneous amplitude of a modulating signal by keeping the two other characteristics such as the amplitude and the phase of a carrier signal constant. The frequency of carrier signal is we call as the center frequency, or it is we called as the resting frequency. Now we will see the waveforms of the frequency modulation. These are the three waveforms. Of the modulating frequency modulation. From that, the first one is, for the better understanding, this time not like the amplitude modulation, we considered the first one is the carrier signal. We denote the carrier signal by Vc. The second one is the modulating signal. We denote it by using Vm. And third one is the composite frequency modulated wave. We denote by Fm. Okay, so here the carrier signal frequency is the constant frequency. It is the constant frequency. And for an example, suppose we consider one example for better understanding. For an example, suppose here the frequency of a carrier signal is supposed to be 100 megahertz. It is 100 megahertz. The sine wave modulating signal, the information signal, is having a frequency of 10 kilohertz. It is the 10 kilohertz. Then here, after the modulation, whatever the frequencies we get, that we write down after one term. Here the frequency deviation is there. As the amplitude of, suppose here we are at this point, the amplitude of the modulating signal is now, it is equals to 0. At this point, here see, at this point it is equals to 0 hertz. As it increases from 0 hertz to its maximum value, here there is a peak value. Here I am going to denote Vp, peak value. Okay, so here it is Vp, and up to this point it changes from 0 to the peak voltage. As the modulating signal increases its voltage, then here the frequency also change. From this point to this point, the frequency of a unmodulated modulated carrier signal remains constant, like the unmodulated carrier signal. Here its frequency is 100 megahertz. It means here from this point to this point, here it is equals to 100 megahertz, because here the modulating signal, the information signal, is also having the 0 hertz value. Okay, now after this point, as the amplitude of modulating signal starts increasing, here from this point to this point, here its value, the frequency, also starts increasing. So here it reaches the maximum frequency. Now the maximum frequency is decided by the frequency deviation allowed. For an example, suppose the 100 kilohertz is allowed. 100 kilohertz frequency is allowed for this much change. Then we can say the maximum frequency F maximum is equals to the frequency of a carrier signal plus the frequency deviation. Suppose there is a deviation of 100 kilohertz, then we get the maximum frequency equals to 100 megahertz 10 is to power 6 plus the 100 kilohertz. It means we get here F maximum is equals to 100.1 megahertz. We get it is equals to 100.1 megahertz. It means when we start the modulation, at the start of the modulation, the modulating signal voltage is equals to 0. Modulating signal voltage is equals to 0. So therefore here the frequency remains same. That frequency is equals to 100 megahertz. That frequency is equals to 100 megahertz. And as the amplitude of modulating signal starts increasing, as the amplitude of modulating signal starts increasing up to its peak value, it changes from 100 megahertz to the 100.1 megahertz. Okay, it changes from 100 to 100.1 megahertz. It means as the amplitude of a modulating signal, starts increasing from 0 towards the maximum positive peak, here the carrier frequency, the FM signal frequency also starts increasing towards its maximum value. Now for this example, it reaches up to 100.1 megahertz because we considered the frequency deviation of 100 kilohertz. Okay, so here as the amplitude of the modulating signal again start decreasing from peak value to the reference voltage of 0 hertz, again it come back to its normal value, and its normal value is the 100 megahertz. Okay, so this is what happens if we apply the positive upcycle of the modulating signal? If we consider the negative upcycle, as the modulating signals start decreasing from this point, as the modulating signals start decreasing from the zero reference voltage at this point here, it have the frequency of 100 megahertz, frequency of 100 megahertz. Now the modulating signal start decreasing its voltage from the 0 volts towards the minimum value of minus Vp. So the frequency is also frequency of the modulating frequency of FM signal also start decreasing from 100 megahertz towards the frequency deviation of 100 kilohertz, means we get it is 99.9 megahertz. We get it is 99.9 megahertz. In two sentences, we can say, as the amplitude of modulating signal starts increasing, the frequency of FM signal, or we can say the carrier signal, also starts increasing towards the maximum value. When the peak voltage reaches, the modulating signal voltage is the peak voltage. At that time, it reaches its maximum frequency, and when the modulating signal starts decreasing, again the frequency starts decreasing. For a negative upcycle, we can say, as the modulating signal voltage start decreasing, here the frequency of a carrier signal also start decreasing. It decreases from 100 megahertz to the 99.9 megahertz. This value is we called as F minimum. Okay, so as the amplitude changes, the frequency also changes. The change in the frequency is we call as a frequency deviation. So here this is the simple explanation of the frequency modulation. We have to see some definitions used in the frequency modulation, but once again we recall the process of a frequency modulation. As the modulating signal goes positive, the frequency of the carrier signal increases. The highest frequency occurs at the peak amplitude, means peak voltage of the modulating signal. As the modulating signal amplitude decreases, the carrier frequency also start decreasing, and here this is we call as a frequency deviation. When the modulating signal goes negative, the carrier frequency decreases and continue to decrease up to the peak value of the negative half cycle, means minus Vp. The carrier signal means complete modulated signal. If we consider the FM signal, then this FM signal looks like the compress and decompress. When the frequency is increased, it looks like the carrier signal is compressed, and when the modulating signal voltage is decreased, the frequency decreases, and here we can say the carrier signal looks like stretched. Okay, so here the frequency increases or decreases, that depends on the amplitude of the modulating signal. So as the amplitude of the modulating signal increases, the frequency increases, and it attains the maximum frequency when the modulating signal having its peak voltage. As the modulating signal voltage start decreasing, then the frequency also start decreasing, and at that time it reaches the minimum frequency when the modulating signal reaches the minimum voltage minus Vp. The waveform, if we see, then it looks like compress and decompress, or you can say compress and stretch. Okay, the change in the frequency is we call as a frequency deviation. We have to see some definition from the frequency modulation. Then in next video lecture we will see the examples on the same. Okay, so it's time to see some definitions of the frequency modulation. Some important definitions we are going to see, which are asked in our examination. So the first is the center frequency. As earlier we said, the frequency of unmodulated carrier signal, the frequency of unmodulated carrier signal is we called as a center frequency. It is we also called as a resting frequency. After modulation, the carrier frequency may change up to the maximum and up to the minimum. It changes from minimum to the maximum. So just we have to keep one thing in mind. The center frequency is the frequency of a carrier signal. It is we also called as a resting frequency. Then second one is the frequency deviation. We had seen just before what is the frequency deviation. The amount of change in the carrier frequency produced by the modulating signal is known as a frequency deviation. For an example, the center frequency, the carrier frequency is 100 megahertz, and this is we call center frequency. When there is a peak voltage of a modulating signal, at that time it reaches the maximum frequency and it goes to the 100 point. The maximum frequency is supposed to be 100.5 megahertz. Then the frequency deviation, the amount of change in frequency is equals to 500 kilohertz. The 500 kilohertz is we call as a frequency deviation. So the frequency deviation is the amount of change. Frequency deviation is the amount of change in the modulated frequency. So here the frequency deviation is important. Then next definition is the modulation index. The modulation index is the ratio of the modulation index is the ratio of the frequency deviation. Modulation index is again denoted by M, and it is the ratio of the frequency deviation Fd to the modulating frequency Fm. For an example, the frequency deviation is supposed to be 100 and the frequency deviation is supposed to be 100 kilohertz and the modulating signal frequency is the 10 kilohertz, 10 is to power 3. Then we can say there is a modulation index of a 10. Modulation index, as it is a ratio, there is no unit for the modulation index. Okay, so the modulation index is the ratio of the frequency deviation Fd to the Fm. Then this next definition is the percentage modulation. In frequency modulation, the percentage modulation is the ratio of actual frequency deviation. It is the ratio of the actual frequency deviation to the maximum carrier frequency deviation allowed. Maximum carrier frequency deviation allowed multiplied by 100. As per the FCC standard, some frequency deviation is allowed. Maximum frequency deviation is allowed. For FM, the maximum audio frequency deviation is 75 kilohertz. It is the 75 kilohertz. So here actual frequency while doing the frequency modulation, suppose the actual frequency deviation is 10 kilohertz. Actual frequency deviation is the 10 kilohertz and the maximum frequency deviation allowed is the 75 kilohertz, then the ratio of this multiplied by 100%, this is we call as a frequency percentage modulation. The percentage modulation is the ratio of the actual frequency deviation to the maximum carrier frequency deviation allowed. You get it very clear when we see the examples on the modulation index and the percentage modulation. The frequency modulation, in the frequency modulation, the percentage modulation is the ratio of actual frequency. While doing the frequency modulation, the actual frequency deviation to the maximum carrier frequency deviation allowed is we call as the percentage modulation. Its formula is given as percentage m equals to actual frequency deviation to the maximum carrier frequency deviation allowed multiplied by 100%. Then we get it is the percentage modulation. The maximum carrier frequency deviation allowed is the 75 kilohertz for FM and 25 kilohertz for the television audio signal. Actually, the television video is in the amplitude modulation, but the audio is in the frequency modulation. So, the maximum frequency deviation allowed is 75 kilohertz for the audio of the FM station, and the 25 kilohertz for the television audio. Okay, so here there may be one MCQ on this. There may be one MCQ asked on this. The maximum carrier frequency allowed for the FM is blank space. The option may be 75 kilohertz, 100 kilohertz, 200 kilohertz, and the 150 kilohertz. Then the answer is the 75 kilohertz. The next definition is the deviation ratio. The deviation ratio is the ratio of maximum frequency allowed, the maximum allowable frequency deviation to the maximum modulating frequency, maximum allowable frequency deviation to the FM maximum. Means here the deviation ratio D is equals to FD maximum frequency deviation allowed. In the previous definition, that definition is of the percentage modulation, the actual frequency deviation to the maximum carrier frequency deviation allowed. It is the ratio, and that ratio is we call as the percentage modulation. Here in this, the maximum allowable frequency. Suppose the maximum allowable frequency is 75 kilohertz and the maximum modulating signal frequency is the 10 kilohertz. Then this ratio is we call as a deviation ratio. This ratio is we call as a deviation ratio. Okay, so this is all about the frequency modulation. Once again, we see the definition of the frequency modulation. So the frequency modulation is the process of modulation in which the frequency of a carrier signal is changed in accordance with the change in the amplitude of a modulating signal. We can say the instantaneous amplitude of a modulating signal by keeping the other two characteristics such as the amplitude and phase are constant. This is we call a frequency modulation. In frequency modulation, the carrier frequency changes to the maximum frequency when there is a change in the maximum change in the modulating signal. If there is a negative peak value of the modulating signal, at that time the FM signal attains the minimum frequency. So as there is a change in the amplitude of modulating signal, there is a change in the frequency. The change in the frequency from the modulate from its center frequency to the maximum, or the change from the center frequency to the minimum, it is we called as a frequency deviation. Okay, so this is all about the frequency modulation. If you understood the video lecture, then hit the like button, subscribe the channel. Thanks for watching the video. Take care.